Are you okay? All right. Any of these that you guys have questions on from the worksheet? All of them.
All of them. You guys didn't watch the video. I literally switched over my notes.
Sabrina.
Number 6.
6. What'd you say, Sabrina?
Instead of getting like 2, 3, 2, I got only 3 and 2 on the outside.
All right, let's take a look. All right. We're not going to forget about this 2 that's already out. It already made it out, okay?
Paste the picture, I won't work.
I've been doing this for 17 years.
Since you were 17?
Longer than you've been alive.
Wait, that's a lie.
I'll take care of this.
I'm 19.
All right, so we got to break up.
17 years is a long time.
Thank you. We got to break up 252. Some of you, listen, I think, how many of you are like completely confused on the homework of the worksheet? Be honest with me. Show yourselves. Okay. If you are completely confused, no shortcuts. Don't do any shortcuts. Okay? Mr. Parker showed you a couple shortcuts yesterday. Don't use them. You should be breaking up 252 into its primes. All the way. Okay? Now, here's a bad idea. If you say 252 is 2 times what? Don't write that down, but I will. 126. And you go 2 times. This is going to take a while. Do you agree? It's going to take a lot of lines. You probably want to try to find another number that goes into 252 that's more than 2. All right. Huh? 14 and 18? Yep. And then 14 is 7 times 2. Is it down to its primes? Yes. 18 is 2 times 9. Is it down to its primes? No, 9's not prime. Now, here's where Mr. Parker and I vary a little bit. Okay, watch up here. He will write 3 times 3 and then circle them once they're prime. I keep dropping these down so that I don't forget to write them somewhere. Like he might have some numbers up here and then some numbers down here. It's just a style difference, okay? I recommend if you're confused on this, you write it out all in the same line. Ready? Quick question for you. Let's see if you really understand this. What's 7 times 2 times 2 times 3 times 3? 252. We just broke up 252 into its primes. Do you understand that? So isn't this the same as the square root of 252? Okay, now we look to see if there's any pairs. Why does a 2 come out? Give me the reason. Why does a 2 come out? Who can raise their hand and tell me? Zachary.
Because it equals 2 squared and you have to square root it.
Yeah, when you square root 2 squared, you get 2, and a 2 comes out. Right?
Mm-hmm.
How about, and by the way, he circles every little prime. I circle pairs, just so you understand why we do things differently. Okay? A pair of 3s, what comes out? A 3, because that's 9, and the square root of 9 is 3. Comes out as a 3. Right? What's left inside? 7. 6 times the square root of 7 is what? That's just the square root of 252. Do you agree? 6 times the square root of 7. Don't forget the 2. We get 12 times the square root of 7. Is that what was on the worksheet? Yes. Does that make sense? Those of you who were confused on the homework, does that make sense? Any others?
We do 9.
9. Oh, I mean, yes. All right. Where do we start, Aaliyah?
You can start with the number.
Yeah. So we're going to learn a property that says this. Are any of these ones really easy to solve that we know just off the bat? Yeah. What is b to the 4th after you square root it? B squared, right? So this one is b squared. Do you agree we're going to have to do some work on this one, and we're going to have to do some work on this one? And once we have them all, then we can write them out in radical form. Okay? So we're going to do this like 3 separate problems. Let's do the square root of 864 first. Aaliyah, help me out.
36 and 24.
36 and 24. Now, what's 36, Aaliyah?
6 times 6.
Good. What's 24?
6 times 4.
6 times 4. Should I stop or should I keep going?
Keep going.
Yeah, so here is the Mr. Parker trick shortcut. It works, but it makes me a little nervous for some of you. He would say a pair of 6s. What comes out? 6. Because isn't this still,
Yeah.
isn't that 36, and the square root of 36 is 6? If you're okay with that, that's fine with me. I just think some of us just aren't quite ready for that yet. So I would recommend keep going. For some people, 3 times 2, 3 times 2,
I did 3 times 3.
for 6?
Yeah.
Oh, that's not right.
Yeah.
Are those all prime?
Yeah.
Yeah. What's 3 times 2 times 3 times 2 times 3 times 2 times 2 times 2?
684.
864. Ready? A pair of 3s. What comes out?
3.
A pair of 2s. What comes out?
2.
Any more pairs of 3s?
No.
But pair of 2s. What comes out?
2.
2. What's left inside the square root?
3.
A 3 times a 2. A 6 is left inside the square root. 3 times 2 is 6, times 2 is 12. 12 times the square root of 6 is this in simplest radical form. Ready? We have our 12 radical 6. Now it's time for the green. We're going to do the square root of a to the 5th. A to the 5th is a times a times a times a times a. A pair of a's, what comes out? A pair of a's, what comes out? A. A. What's outside? Radical. A. Okay. Question for you. How the heck should we write this? Sabrina, I saw your hand first.
We should do 5
12a squared,
then b squared,
b squared, and then the radicals.
then 6a.
Good job. Yeah. 6a.
Can I get my cookies?
Yeah. Which one were yours?
The giant boxes.
All right. That is our final answer. That's our final answer. It's not as bad as you guys are making it, was it? Properties of radicals. Not radical properties. I've already introduced you to one of them. The square root of a times b is the square root of a times the square root of b. Did I just do that one to show you how we did it as 3 separate problems? Right? There's a reason for that. So this is often used to simplify square roots. This is what Mr. Parker was kind of showing you guys. Like the square root of 18 is the square root of 9 times the square root of 2, isn't it? Now, couldn't you do 9 as 3 times 3, a pair of 3s, a 3 comes out? Or if you see it now, we're another day into it. If you see, oh, well, I know the square root of 9, it's just 3. I don't need to break it down into pairs. I already know the square root of 9 is 3. That's fine. What would number 2 be in simplest radical form?
Should we just say the answers?
Yeah, the final answer.
2. Oh, wait. Is it the bottom or just number 2?
So this turns into this. What's the simplest radical
2
form?
squared radical 2. That's what I thought. That's just for the 32. I'll look at the bottom part.
Okay, wasn't 32. They're skipping a step. They're saying this is 16 times 2. Not really skipping a step. They're just not writing. I'm not. When we do that, we don't write the square root there, right?
2 squared.
Isn't 16 4 times 4?
Yeah.
What comes out? You could keep going. You could go 2 and 2, 2 and 2, and 2. They're trying to get you to see that this is the square root of 16 times the square root of 2. Doesn't a 4 come out if we do it this way? Isn't the square root of 16 4? Same thing, just a different way of thinking about it. Does that make any sense? So what's our final answer in simplest radical form? 4 times the square root of 2. Or if you want to get radical.
That's the same thing as 2 squared.
2 squared, but yeah, we would write 4.
You have to write 4?
Yeah. How about this one? Simplest radical form.
Times 5.
What's outside?
5
What's inside?
times 2.
5 times radical 2. You get it? Go ahead, Aaliyah.
I think I just got confused. You said what's inside and then you said 5 times radical 2. But that's, oh, yeah, that's it. Never mind. You had that on the paper.
What's next on your paper?
Yeah.
Square root of 45? Go ahead and write that in. Simplest radical form. Hey. Either way you did it, what we did yesterday with the arrow, the tree, or this method today, did you get 3 radical 5? Good? Radical 72? Uh-oh. Careful. Logan, what'd you get?
Can you do 36 and 2?
Could.
6 and 2?
6 times 2 is not 72. Anybody do 9 times 8? What'd you guys get for your final answer? 3 radical 8?
I got 3 times 2 radical 2.
So here's the problem. This happens a lot. Everybody freeze what you're doing and look up here. This happens a lot. This is the square root of 9. Pretend that's a square root. Oh, that's getting glitchy. This is the square root of 9 times the square root of 8. I agree that the square root of 9 is 3. Is radical 8 in its simplest form? No, there's another perfect square that could have been pulled out. Isn't 8 4 times 2?
Yeah.
We could have pulled out another. Right? Radical 4 times radical 2. We could have pulled out another 2. 3 times 2 is 6 radical 2. So be careful. At this step, if you don't keep breaking it up into its primes, you run the risk of not getting the simplest radical form.
Wait, so 6 and 2 are right? 6 radical 2 is right?
6 radical 2 is right. You said 6 and 2.
Oh, it's not 6 radical.
When you said 6 and 2, I thought you meant those were the numbers that multiplied to 72.
12 and 6.
How do we feel? Who's like at a 7 to 10 out of 10 as far as understanding? 7 to 10. Okay, then I'm going to add one more thing to check, for you to check. How can I check this answer other than a calculator? Well, I'm going to teach you something real quick. All right? Hopefully it doesn't confuse you. I need you to focus. What's 6 squared? Times 2.
72.
To put this number back into the square root to check it, wouldn't I square the number on the outside? Right? It came out by square rooting. If I want to check it, wouldn't I square it times that number inside to check my answer? It should always work out. Let's do this one. What's 3 squared? Times 5. Should work out that way. Okay, just a quick check. Next. All right. So we need to understand the definition of simplest form for square roots. Step 1, the radicand should not have any perfect square factors other than 1. That's why that radical 8 in the last problem had a problem. Radical 8 had a perfect square inside of it. You needed to keep going. All right, so that one. Next one, the radicand, number inside, has no fractions. So this one has an issue right here. All right. And lastly, there are no square roots in any denominator. This one has an issue. There's a square root in the denominator. All right, I'll show you how to take care of that. We're going to multiply by 1. If you multiply by 1, do you affect the problem at all? So we're going to multiply by 1 in disguise. So we don't affect. What?
Just like so.
Where did Mr. Westphal go? I don't know. He's disguised.
What's the jumper thing?
Oh yeah.
Whoa.
Here, I'm right here.
Yeah.
All right. Is radical 8 simplified? No, isn't it? Do you guys like the tree way or the radical blank times radical blank way?
Three.
Tree. Okay. 4 times 2. 2 times 2 times 2. What comes out?
2.
What's left inside? 2 radical 2. 2 radical 2. Completely simplified. Next. All right. This is a new one to us. This is radical 2 over radical 5. Radical 2 over radical 5. Am I completely simplified? What's the issue? There's a radical in the denominator, and according to our rules, can't be any radicals in the denominator. So we have to do something. We have to multiply by 1
On both sides.
in disguise. There's no both sides.
On both.
On top and bottom.
By what?
1.
Times 1? Times 1? What do you get?
2.
Radical 2 over radical 5. Did that do anything?
No.
No, so you need to multiply by 1.
X.
Not by 1. By 1
In disguise.
in disguise.
Oh,
What does that even mean?
no way.
Zachary.
1/2.
This might sound dumb, but would you
It might.
use a negative exponent?
No. Let's take a try.
Said it might sound dumb.
A negative 1 and a positive.
What would get rid of a radical? We don't want a radical 5 in the denominator because that breaks the rule.
Square
We need to multiply by what to get rid of the radical?
Itself.
Itself. Ready? If I multiply the denominator by radical 5,
You're just mad that
am I allowed to multiply just the denominator by radical 5? I need to multiply the
numerator.
by
2.
radical 5.
5.
No, we have to multiply by 1.
So it's
In
like
disguise.
In disguise.
In
You see how radical 5 over radical 5 is just 1 in disguise.
Wait.
You'll remember it. I'm being stupid for your sake. I don't want to be stupid and silly. It's just it has to
Michael
happen.
would tell me otherwise.
Huh?
Michael would tell me otherwise.
You just said it.
Possibly.
Who's Michael?
Micah.
It's my son. It's my son.
There you go.
What's radical 2? What's radical 2 times radical 5? Radical 10. What's radical 5 times radical 5?
Radical 25.
One.
Not
1.
In disguise.
Radical 25.
Children. Children.
Yes.
What's radical 5 times radical 5?
3.3.
Oh my god.
One.
Huh?
One. In disguise.
Radical 5 times radical 5 is 1?
3
Disappear.
point.
3.3.
You can't do it.
It
What?
disappeared.
Alright, my confidence is one below average.
You guys are silly.
Radical 5 times radical. Oh, we have to simplify it.
What? What?
Oh,
No.
wait, no, you can't.
You
What?
can't- Oh, my God. I'm
You can't
confused.
simple 5.
What's radical 4 times radical 2? It was radical 8, wasn't it?
Yeah, radical 8.
What's radical, like, what if we got like this?
It's 10 or 25.
It's radical 25.
Isn't this radical 3 times radical 5 times radical? What's radical 5 times radical 5?
25.
5.
5.
5.
It's 5.
Shoot, he's right.
If you said radical 25, okay,
I was just listening.
but what's the square root of 25?
I get it now. 5.
That's 5.
Oh, I get it.
What's radical x times radical x? X. What's radical 2 times radical 2?
2.
What's radical dog times radical dog?
Dog.
Dog.
Dog radical.
That is not correct.
Goat.
Now,
What's radical goat times radical goat?
go.
If you get it wrong, you might
No.
make it bleed.
What?
Wait,
Back to the story. What's radical 5 times radical 5?
5.
Five.
Radical.
Not radical, just 5.
Oh.
Just 5.
Just 5, Bree. Yeah, damn it.
Oh my
So
goodness,
now you can do
people.
the same thing to the 10. Make it out of the radical.
What's the square root of 9?
3.
It's 3. Isn't it because this is 3 times 3? Isn't this radical 3 times radical 3?
Oh, yep.
What's radical 3 times radical 3? 3. That's the definition. If you multiply a radical times itself, you get the number. That's the definition. You with me? Awesome. All right, everything's good in the world. Or is it?
Oh, great.
It is. Or is it?
Guys.
So,
What's the issue? Go ahead, Sabrina.
is that the answer now? We don't do anything else?
Radical 10 over 5
The answer?
is the correct answer. Question for you.
Answer?
Is the value of this the same as the value of this?
No.
Yes.
Yeah.
They're different. We changed the value of it.
No.
No.
They're the same.
Is the value of this the same as the value of this?
Yes.
Yes.
In
In
disguise.
disguise.
It looks different, doesn't it?
It's all about perspective.
No.
Dude, are you trying to be difficult, or do you really not understand?
No, I get
Okay, you're just trying to be difficult.
No. I
You don't understand?
No, I get it.
It's one of the two.
No, I get it.
Awesome. Is this okay as it is?
No.
What's the issue?
24.
The 24 is not the
Oh
issue.
no, it's a 2. It's in the bottom.
You go through your sequence. Is the radicand, does the radicand have any perfect square roots? No.
What is a radical?
The inside of the square root. The radicand has no fractions. Well, this radicand is 2. Does it have any fractions? That's not the issue. There are no square roots in any denominator. That's an issue. There's a square root in the denominator.
Keep change what?
We don't want that radical to be in the denominator. It's okay. We're going to multiply by 1. Too far.
Wait, what's How was that too far?
How do we multiply by 1 in disguise?
2, 2.
Not by 2.
Whatever this is.
2 in disguise.
I've said it probably 100 times today alone.
Radical.
Radical 2 over radical 2. Whatever the denominator's radical is, you have to multiply it by itself to get rid of the radical. Isn't that the definition of a square root? If you multiply it times itself, the radical disappears. All right? Radical 2 over radical 2. Are we changing the value of the problem?
No.
Because we're multiplying by 1 in disguise. What's the numerator?
48.
Oh my gosh. What's the numerator? What's 24 times radical 2?
Radical.
Holy smokes.
Just 48.
Radical 48.
If it was the square root of 24 times the square root of 2, it would be radical 48.
24 radical 2.
24 radical 2. Thank you.
Oh.
Okay.
Hey guys, what's 3 times radical 7? 3 radical 7. Nothing can be combined. What's radical 3 times radical 7? Radical 21.
21.
Do you agree? This does not have a square root. What's 24 times radical 2? 24 radical 2. What's radical 2 times radical 2? Just 2.
Ooh, by itself.
If you say radical 4, okay, but simplify it. What's the square root of 4? 2. It's just 2. What happens when you cut something, when you divide something by 2, you're cutting it in half, aren't you? Can this be simplified at all?
Yeah.
What's half of 24 apples? 12 apples. What's half of 24 radical 2? 12 radical 2. This is 12, 24 over 2. Those can simplify. These cannot. These cannot. 12 radical 2. Who's completely lost?
Would that be simplified? Or can you simplify it?
How would you simplify it more?
I guess it's
Can't. Here's how you can tell from now on. Are there any numbers inside the square root that can be broken down into pairs? No. Are there any square roots in the denominator? No. Bless you. And can any numbers outside be multiplied together? No. All right. So that's the property we just used. We already used the quotient property
None of those problems were on our paper.
in the guided notes.
Yeah.
You're on to-
So we're up to this now. This is your first problem. That was all just a little warm up.
Yep.
You're welcome. All right. You guys can do this one on your own. I'll give you a hint. You don't need to multiply by anything in this, guys.
I forgot everything.
I feel like I'm in Men in Black. That mind eraser thing. It's like I didn't even use it, but like.
Actually,
All right, let's rewrite radical 7 over 9. First of all, do you agree there's a problem? There's a fraction inside the square root. There's a problem. It's okay. How can we rewrite radical 7 over 9? Radical blank over radical blank. Radical over radical 9. Now, you may think I'm about to break a rule that I just made, but I'm not. Could I multiply by radical 9 over radical 9? I could. But before you do too much work, see if any of these can be simplified.
yeah.
Can radical 9 be simplified?
Yeah.
What's the square root of 9?
3.
3. And that makes this problem really nice because it's done now. Radical 7 over 3. Are there any radicals in the denominator now? No. And you go through your bullet points. Do I have any radicands, the numbers inside the square root, that can be broken up into pairs? No. Do I have any fractions with radicals in the denominator? No. And do I have any fractions inside the radicand? No. That is completely simplified. What do you think?
It looks scary.
Logan?
It would just be 7 over 5.
Is the square root of 14 7? Let's do the square root of 14 over the square root of 25x squared.
3
Nope, that should not be ever any decimals.
should it be fraction?
The simplest radical form.
Oh.
No decimals.
Huh?
Or would it just be 17?
Isn't 14 7 times 2?
Yes.
Are there any pairs that come out? No, so radical 14 is simplest form. Leave it alone. Next, move to the denominator. Isn't that the square root of 25 times the square root of x squared? Yes, yes, yes. Can those be simplified? Yeah, we have, let's leave the top, radical 14. What's radical 25? What's radical x squared?
X.
Thank you. That is simplest. Radical form. Isn't it beautiful?
Simple.
Simple. It's radical. I mean, some say it's radical.
Minimalistic. I'm not done with 8.
Huh? It's like the color of my car. My car's about to die. I feel bad for it.
What?
Yeah. I have to get a new one soon.
You could see her?
I got a screw in the tire last night.
What's her name?
Uh,
You know her name?
Sabrina?
For number one, so for, would you count it all for the test that we did, radical 63, and then
Huh?
would you, like, if you did, like, do all, like, the harder work, would you, like, count it off instead of doing that? Like, so, like, you did, like, radical 63 and then, like, 9/9.
Oh, this is painful. Yes, radical 63, Sabrina, is not simplest radical form. What's radical 63? Isn't it 7 times 9? So couldn't the numerator be 3 radical 7 over 9? And isn't 3 over 9 1/3? This is supposed to be a 7.
So would you simplify?
Yeah, so you have to keep simplifying. So it's not wrong, but well, it's not all the way right either, though. You have to get points off. All right, let me see those guided notes. Ooh, I think those are some great opportunities for you guys to do. I'm not going to give you much homework. Just finish the guided notes. All right, feel? Yeah. Now, don't just rush through them. Do your best. I'll take those answers. What do they call them? Worksheet answers. I'll take them up here, right here. Have a wonderful weekend. Have a fabulous Friday.